To work out the combined resistance between series and parallel resistors, you do the parallel ones first to work out the total resistance in the junction, and then you add any in series. So the total resistance in the parallel is 1/4 plus 1/4, which is a half. Therefore, the total is 1/1/half. 1/half, which is 2. And so the real total is 2 for this section, plus the 4 in series, so it's 6. So it's B. Question 37, we've got another potential divider. Don't be put off that they're saying negative temperature coefficient. What that means is what you're used to. As temperature increases, resistance decreases. That's what that means. The negative means it's like an inverse link, an inverse proportionality, if that makes sense. So we've got the thermistor at X, and then we've got a fixed resistor at Y, and then it's saying what's going to happen. Okay. So the first thing that we need to know is what's going to happen to the temperature. So it says the temperature of the room increases. So actually, I've already written that here by chance. The temperature of the room is increasing. So the resistance of X is going to decrease, which means that the voltage across X will decrease, because they do the same thing, the same ratio change. So that's going to decrease as well. Now, if Rx drops, then, and Vx is dropping, it means that Vy is getting a bigger share of the total voltage from the cell. Okay, because Vx plus Vy equals V cell. I could write that here just to help. So if Vx's share drops, then Vy gets a bigger share of the cell. Okay, so Vy is going to increase. And if the temperature of the room is increasing, then the current is going to increase as well, because Ry is fixed. It's a fixed resistor. We can see that by this symbol. Okay, so the total resistance in the circuit is dropped because Rx's has dropped. So therefore, the total resistance has dropped, which means that the current in the circuit has increased. So we're looking for an increase in current. We're looking for an increase in voltage in Y, and we're looking for a decrease in voltage in X. So it's B. Okay, we've got a resultant force calculation here. We've got it's at constant height. Okay, so it's in equilibrium. We've got upthrust, weight, force due to wind. The magnitude that the resultant force acting on the balloon is. Okay, so we've got 10-2 up and 9-8 down, which equals overall one minus the other. So the resultant is the up, you could call this a negative if you want, plus the down. So that's 400 up. We also have a 300 across. So we have a 300 across. Okay, let's draw this. So we have 300 across. We have 400 up. And we need to find the hypotenuse. Okay. It's one of the Pythagoras triangles where it goes 3, 4, 5. Hopefully you know it. 3, 4, 5. So we're just adding on 2 zeros. So 500. Question 39. We've got a body initially at rest, explodes into two masses, m1 and m2. They move apart with speeds v1 and v2. What is the ratio of v1 over v2? Okay, so it starts off at rest, and then it explodes, and we have two pieces break away. Explosion. Okay. So this one is M1, this one is M2, V1 and V2. Okay. Now, we know that initially its mass times velocity was 0 because it was stationary. Okay, so its initial momentum was 0, which means its final momentum has to be 0 as well. So let's treat these as vectors, shall we? So let's say that if we've got m1 v1 moving in one direction, that's going to equal m2 v2 moving in the other direction. Because then m1 v1 equals m2 v2, and therefore one minus the other equals 0. And so we're trying to find what v1 over v2 equals. So if I take the v2 over, so v1 over v2 equals m2 over m1. So that should be one of the answers, B. And then the final question is looking at units. A volt can be defined as, so we need to know our formulae. So volts, so we've got options are charge divided by energy, charge divided by time, C is energy divided by charge, and D is energy divided by time. Okay, so energy divided by time is power, so it's not D. Joules per coulomb, energy divided by charge is volts, so it should be C. Well, let's just double check. Coulombs per second, charge divided by time is current, so it's not B. It's looking promising. And coulombs divided by joules, charge divided by energy is 1 over volts, so you might have put A if you just got your equation upside down. But final question of the higher paper, question 40, is C.